Good evening, everybody. Let's begin today's webinar. So today's webinar is a interesting topic. Basically, it's about the mistakes every CNC beginner makes and how to avoid them. Today, actually, we are not here to judge the mistakes. We are here to understand them. Every CNC expert you admire today has made the same mistakes at the beginning. The difference is simple. Some people learn from the mistakes, others repeat them. By the end of the session, you will be knowing what to be careful about before pressing that cycle start button. So, one small CNC mistake can break a tool, it can scrap a job, or even damage the confidence. But learning from others' mistake, it costs nothing. Okay, because CNC machines are very expensive, and any small mistakes are costly. Getting knowledge is the cheapest way. It is cheap. So we can learn from others' mistake, and then we can reduce the fear, and then increase the confidence. You have to actually in the CNC, you may be an operator, not just an operator. Now, who is this session for? This session, if you're new to the CNC or still feel nervous near the machines, this session is for you. Even experienced people, they will also recognize some of these mistakes. So if you're CNC students or freshers or new operators or beginners in programming, you will be benefited by this session. Now, CNC machines, the simple truth. CNC is accurate. Yes, CNC is very, very accurate. CNC is obedient. It's very obedient. Whatever we tell, it will do the same way. But CNC does not think. The CNC machines don't have the thinking power. They do not understand the drawings, the jobs, or they cannot recognize the mistakes. They only do exactly what we tell them to do. So the quality of output depends entirely on our thinking, not the machine. The machine does not think. Now, what are the mistakes? So let's see the mistakes. First mistake is not understanding the drawing. Without understanding the drawing, it's like machining without any clarity. This is the number one mistake. Beginners often look only at the dimensions. They don't check the tolerances, they don't check the surface finish, they don't check the functional areas. The machining always starts in the mind, not in the machine. It should start in the mind. Now, what goes wrong? If you don't understand the drawing properly, what is going to happen? When the drawing understanding is poor, the part inspection will fail. Parts will fail in inspection. Supervisors will lose your trust. Confidence gets dropped. And it will also, it will also lead to rework or scrapping. What is rework or scrapping? The entire work, since the operator did not check the drawing properly, he has to do again rework on all those things, or he has to scrap that piece and do it again. Now, most of the rejections in the CNC are never machine errors. They are not errors caused by the machine. They are actually the cause because the drawing was not understood well, or those were the drawing errors. Understood? Now, how to avoid How to avoid it? There's a simple technique. Before machining, you have to ask yourself which dimension is critical, which surface is functional, which tolerance matters the most, or would say we have to identify all the critical features, and you have to read the entire drawing, or you have to check the entire drawing of for all the markings. You have to see if there are any special markings, special tolerances told, or roughness told. All these things has to be identified first itself. If you have any doubt, ask it before starting the work. 10 minutes of drawing checking. You check the drawing for 10 minutes before start. It will save hours of work. Imagine you're working on the CNC for around, your program is around 7 hours or 8 hours or something. And then at the end of the 7 hours, or when it is at 99% progress, you are realizing that the program is, the drawing read was wrong. This was not the finish we wanted, or this was not the critical dimension. Everything, the piece gets rejected. So to avoid that, always a first 10 minutes of drawing checking will help you. Now, what is the second mistake? So first mistake I told. Now we are going to the second mistake. It is wrong zero setting. What is wrong zero setting? Zero setting means setting the reference. Zero setting is the foundation of CNC machining. If zero goes wrong, everything goes wrong. Many beginners, what they do, they just assume zero. Without confirming it, they assume, okay, this is the work zero, or this is a tool zero. These things are assumed, which causes the crash or damage. These things, the zero has to be confirmed before the start of the program. Now, common zero confusion. What are the common zero confusions? The beginners often they mix. What is that? Machine zero, work zero, tool zero. These three gets mixed and get confused. See, a CNC machine will never forgive the wrong assumptions. What's happening? The Z is top or bottom. Which work offset? Tool length mismatch. What will happen? See, if this is your job, if this is your work, the zero can be set. The zero can be set either at the bottom or at the top. So if it is at bottom, if this is for example 20 mm height, so what will happen? Here it will be 0 and top will be 20. So when you give the cut, it has to be 20, 19, 18, 17. Whereas if you are putting the top 0, the 0 is on top, what will happen? The dimension you have to put will be, the Z depth you have to put will be 0, minus 1, minus 2, minus 3 till minus 20. That itself is a main problem. You have to identify where the work Z bottom or Z is set. Z is set on top or the bottom. Now, next thing is where is the work offset? What is work offset? So work offset in a table, like we discussed in the last class also, there may be 5 or 6 jobs sometimes. So what we will do? We will just give one coordinate for each. So one will be G54, G55, 56, 57, 58 or 59. Or if you have more, you can even go for G54 part 1, part 2, all those things. So what happens? When we work, before we work, we have to check whether the exact work offset has been selected. That is, if you are working on the piece set with G54, you have to work on G54 itself. If not, you have to work on G55 or G56. You have to check whether which is the coordinate mentioned in the program. The tool length mismatch. What will happen? You have to check whether the G43 value, there will be always a value G43 along with H and a tool H and a number. You have to always check the tool number which you mentioned first. For example, M6T6, the tool number 6. If tool number 6 is used at the G43, you should make sure that H6 has been put. Now, how can we avoid it? So, to avoid this, first we have to design the zero clearly, we have to verify the offsets, and dry run has to be compulsorily done. So, what we will do? We will do the dry run or use the single block. Single block, what will happen? BCs here, the cutter will come. Once it is nearby, around 30 mm above, you will stop there and you will check what is the dimension. Okay, the display shows 30 mm, and here also, okay, it is 30 mm, approximately 30 mm. You have to visually check it. Then you will do the single blocks. So you know that CNC programs lies in multiple lines. So once you give the single block, what will happen? It will go only line by line. Go one line, stop. Press the cycle, start again, it will go to the next line. So when you are doing, if a batch production or anything, if you are doing the first piece, always go with the single block. And always keep your hand near the feed hold or emergency stop. Confidence always comes from verification, not hope. Confidence has to come from verification. Verification has to be done every time. Now, third mistake. What is the third mistake? Third mistake is blindly trusting the program. Blindly trusting the program. What is happening there? Program is not the enemy. Actually, the assumptions are. A program may be perfect, but the tool length, offset, or setup, they may not be perfect. There will be errors in them. We never trust blindly. Always we have to verify intelligently. We have to check if the tool length offset is given correctly. I told you G43. Then or the coordinates, all these things has to be checked. We should not blindly, okay, the programmer gave me the program. This should be correct. I will directly run. No. Once the program is received, you have to again manually check what are the settings given in the program. Now, what will happen? One wrong digit in the offset can cause, it will give the wrong tool number or wrong offset value or wrong tool length. Anything can happen. So what will happen? One wrong digit in the offset, it can cause tool breakage, job to be scrapped, or it can even damage the machine. The machines are powerful. Errors becomes expensive very fast. For example, if you put instead of G43H, I am using tool number 6 and you are putting tool number H value you are putting as 8. The machine will take the height of only the 8th tool, not the 6th tool which we need. Then instead of this G43, use some other codes. Again there will be error. Instead of H, you put some T or something. Again there can be errors. All these things has to be checked. Before giving the Z value, you have to put the G43 H, what is the tool number. All these things has to be done properly. Now, next, safe first run practice. What is the safe first run practice? The first run practice is nothing but you have to, first run is not about the speed. It's all about the safety. The first run, as I told a little earlier, the first run always has to be a slow run. So we will do the dry run, we will do the single block, or even we will do the feed override. What? We will not give, if you have given 1000 mm per minute, we will reduce the speed to 10% or something. So it will go only in 100 mm per minute. So we can see how the work is going on. In the starting, in the G0 rapid override, we will reduce it to 2% or 25% so that it goes very slowly and we can always confirm that the works are going well. Now, let's go to mistake number 4. What's mistake number 4? The mistake number 4 is nothing but the wrong tool selection. A tool decides the performance. If we select the wrong tool, what will happen? It can lead to poor surface finish, it can lead to vibration, it can lead to tool breakage. This tool selection is a skill, not just a guesswork. Understood? Now, What are the common tool errors? Common tool errors is we use the wrong material tool or too long tool or wrong fluid count. See, every tool should be selected based on the material. For aluminium, we have to use this sort of material, this tool or that tool. There is for HSS has to be used only for certain tools, materials. Carbide has to be used for hard materials. Coated carbide has to be used for some other type of materials. Beginners, what they do, they will just select the tools or choose the tools based on availability, not sustainability. The longer tools look convenient, but increases vibration. So always we have to see that we are using the right tool and the right length. We don't keep more length in the tool hanging. Now, how to avoid it? So tool selection is where I told beginners silently lost the confidence. Many beginners, what they think, okay, if it fits, it works. No, but in CNC, tool selection decides the cutting stability, the surface finish, the tool life, the machine load, and see, this machine, the tool and the material has to be matched. And you have to use the shortest tool. If you have to go only 25 mm on the material, you can keep only 35 mm extra outside the collet. Keep maximum inside. Keep a safe distance and keep the remaining inside. Now, see, aluminium, steel, stainless steel, cast iron, all behave differently, right? One tool cannot suit all the materials. And the longer tools, as I told, will increase the vibration and give the chatter marks. So if a senior in your company asks, which tool are you using? It is not like they are insulting you. It's like he's trying to save the job. So a good machinist, what they will do? They will select the tools first, not the program. First, machinist will select the tool. He will tell to the programmer, these tools are good. We will use these tools. Okay. Now, we are going to mistake number 5. What is mistake number 5? Mistake number 5 is ignoring feed and speeds. We have learned about speeds, everything in the last. So cutting is a controlled force. You know that, right? So feeds and speeds are not numbers to memorize. They are decisions. Beginners usually do one of the two things. First thing, go too slow out of fear or go too fast out of excitement. Both are mistakes. Why? Going too slow, there instead of cutting, rubbing is going to happen. Going too fast, the tool is getting overloaded and there are chances that it breaks fast. So see, imagine you are using a knife to cut. What will happen? It cuts easily only when the pressure is right. If you press too lightly, it's not going to cut. Or if you cut it too hard, it is going to not be proper. So you have to set the feed and speed properly. Now, many beginners, what beginners commonly do? Many beginners just copy feeds and speeds from the internet or any other machine or from the old program. But they forget that the tool condition may be different, the material batch may be different, machine rigidity may be different. So what we have to do? We have to they just copy the values blindly, they ignore the machine sounds and ignore the chip shape. What we have to do is we have to listen to the cutting sound. When the machine is being run, you have to always listen to the sound. Any small change in abnormality in the sound, stop the work immediately. It will save the machine and the job. Then you have to always watch the chips and also you have to feel the vibration, not just see, you have to feel the vibrations. What happens? These are the ways the machine talks to us. Machine doesn't have language. So what will do? The machine will just talk us in this way. The sound, the vibration, the chips. This has to be understood and we have to learn. We have to learn to listen. Now, how to learn? I told you we have to start with the safe values. We have to start conservative, observe the cutting, and then increase gradually. I told what we'll do. We'll first, when the cutting starts, we'll go with slow. We'll listen to the sound. We'll see how the chips come and how the surface finishes. Then slowly we will increase the feed or the speed. No senior, no one in the company or your seniors will be scolding you for being careful. They will only scold you for being careless. Now let's go to mistake number 6. The mistake number 6 is poor clamping. It's a very risky thing. What will happen? A loose job, a not properly clamped job is a silent danger. The clamping mistakes don't give any warning. The program runs fine. The sound is normal. Then suddenly the job gets shifted. What will happen? Because it's not clamped properly. Then the cutting force will be strong. The vibration just increases the movement, and this job shift, it will damage the tool, job, or even sometimes the machine too. CNC doesn't know whether you have clamped it properly or not. So you should always make sure your job is clamped properly. What are the common complex clamping mistakes? Uneven supports, then loose vice tightening, wrong jaw pressure. Sometimes the jobs may be rusting on the chips. We will not have cleaned the table properly and just we have clamped it. That will be a mistake. Then parallels not seated properly in case of vice. The loose vice, that is, we just hand tight the thing. We don't tighten fully. There is no final check. Then wrong pressure in the sense, wrong jaw pressure when we keep in the vice. Too tight, the job can bend. Too loose, the job can move. So clamping is a skill, not a muscle power. What are the safe clamping habits? So first thing, you have to clean the contact surfaces. The bed or the vice has to be cleaned perfectly, and there should be no dust or oil or chips or anything on the table. Then you have to tighten it evenly. We say always, even if it's a square piece or anything, we tighten it diagonally. We won't tighten it in the same side. We tighten it diagonally. And then before the cycle start, you have to recheck the entire process. What will happen? You have to look at the job, you have to touch the job, and you have to try to move it by hand. Even if it moves even slightly, stop and reclamp. 5 extra seconds of checking saves hours of regrets. That's a safe clamping habits. Now, let's go to the mistake number 7. What is mistake number 7? Poor measurement habits. So, machining without measuring is like gambling. So, what many beginners think? They think that, okay, measurement is not my job. It is the inspector's job or the inspection department's job. No, measurement is machinist's responsibility. Measurements help detect errors early. Late detections means scrap. Confidence comes from knowing the dimension, not hoping that it is right. What will go wrong? Measure only in the end. Wrong instrument choice. No cross check. So some other mistakes include which using vernier caliper, where a micrometer is needed, but you will be using the vernier caliper, or you are just measuring once in one place and trusting it blindly. We are not checking the zero of the instrument. We are not taking measurements from multiple areas, or we are not checking the zero of the instrument, or measurement itself needs a discipline. There is no cross check. Cross check has to be done. Now, what are the good measurement practices? A good measurement practices, where we will do, after the roughing, we will be checking the stock left. Before finishing, we will be confirming the allowance, and after finishing we will do the confirm the final tolerance. Measurement is basically a feedback, not a fault finding. So we'll do it after roughing. Once we do the roughing, we'll be checking for the stock size. Then before finishing, we'll be leaving a small allowance for the final finishing, and after that we'll be confirming the tolerance if the material is within the tolerance. Now, mistake number 8. What is mistake number 8? Mistake number 8 is fear of asking questions. What is the fear of asking questions? So silence. What will happen? Silence creates mistakes. This mistake is psychological. Beginners think, if I ask this doubt, they may think that I am useless, or they may get angry on me. Reality is, what is the reality actually? If you don't ask and make a mistake, there the trust is getting reduced. If you ask a doubt, okay, the people will have trust that, okay, if he has a doubt, he is coming and asking, he is clearing it before starting. But if you keep it in mind and you get this, you did something wrong, and then later you told, oh, I knew this, but I could not ask it. That the trust goes, and it will not be good. Then seniors always, not seniors, everyone prefers questions over crashes. Instead of crashing, they always prefer questions. The asking questions only shows responsibility. It will show the responsibility. Unasked doubts stays forever. It never goes. It just doubts remain like that, and then mistakes repeat because the root cause was never clarified. Questions you ask today, that will prevent the mistakes that will happen tomorrow, and you will lose the confidence also. Okay, so always you have to ask questions. Now, what are the good CNC habits? CNC habits are: 1. Habits decides the careers. Talent helps, luck helps, but habits decide how long you survive in the CNC. What are the good CNC habits now? Think before machining, check before cutting, and measure regularly. Think before, you have to check whether the program is right or the program has any errors. Everything has to be checked. Now, CNC is fair. It does not care where you are. It rewards careful people and punishes careless actions. Speed will come, but accuracy must come first. So CNC always rewards only discipline. CNC punishes carelessness. One small carelessness will lead to big error in the machine or job or anything. So that's all for today. Let's wind up for the webinar for today. If you have any doubts, just message in the group. I'll reply in that. Thank you.